and these are the two important protocols that are available for data communication. But out of these two, only one of them is actually used practically in the networking. So let's explore what these protocols are and how to discuss about these protocols. So in this session, we're going to learn about the OSI model and the TCP/IP model. So these are the two data communication models available, and these were developed way back in the 1970s and 1980s. So when the networking was in a very nascent stage, the requirement for establishing communication between the devices required certain protocols. So after a lot of research and development, these protocols evolved, and the actual protocol that is in use today is the TCP/IP protocol. But we are also going to discuss about the OSI layers, because the OSI layer gives us a in detail functionality of how the host, the user, can communicate with the server. So let's start looking at what is this OSI model and how does it work. So OSI stands for Open Systems Interconnection. It is one of the oldest reference model introduced in the year 1984. It consists of 7 independent layers. So each layer will be performing certain tasks. We will be discussing in detail about the functions of each of these 7 layers. And if you look at, it was originally created as a basis for designing a universal set of protocols called the OSI protocol suite. And the OSI model never achieved widespread success. Remember, we had mentioned a little while ago that OSI is not the one which is actually used for data communication, but it is used as a reference model. You can see here, the model became a very useful tool for both education and development to understand the basic communication models. So Open Systems Interconnection was one of the earliest model that was developed for data communication. And if you look at, these are the 7 layers that we are going to discuss now. So these 7 layers consist of application layer called the layer 7, presentation layer called the layer 6, session layer called the layer 5, transport layer called the layer 4, network layer called the layer 3, and data link layer called the layer 2, and finally the physical layer called the layer 1. So it is important to know the order of these layers. We have to follow this specific order, and this is the numbering system. Starts from layer 7 at the top and goes on till layer 1 at the bottom. So we have to now discuss about the functions that each of this layer performs so that network communication is possible. So let us look at the very basis requirement for why this is required. So let us take an example of this computer here. So there is a computer here, there is a PC, and then there is another PC. We want to establish communication between these two computers. So we require, yesterday we discussed about the various components required for setting up the network. So this switch will be connected to this PC, and this cable will be connected to another PC. So if you look at, this is the switch, and this is PC1, and this is PC2. So to let this computer communicate from PC1 to PC2, we have to send the data from this computer to this computer. So the data should go from computer 1 or PC1 to the switch, and then switch should forward it to the PC 2. So, this is what we do, but how does this computer know the data should be sent to that particular computer? So, for this data communication, a set of protocols are required, and those protocols are designed in this OSI model and the TCP/IP model. So, this first discussion is about the application layer. So, the application layer, what does an application layer do? So, this layer is acting as an interface between the computer and the server. So, basically the users who use a computer to access the resources available on the server has to use the application layer. So, what do we mean by an application? So, basically application is an example, like for example the web browser. So, the web browser we use today to access the web pages or websites is one of the network application. So, we have various kinds of browsers available like Internet Explorer, Google Chrome, Firefox, Safari, etc. So, these are the various web browsers available, and these come under the application layer. So, examples of application layer include web browser and the FTP, file transfer protocol. So, this file transfer protocol is used to exchange data from the client to the server and server to client. Also, we have email, which is a very common. These are some of the examples of the applications, and this purpose is for sending and receiving email, or a laptop or a smartphone. What do we use in those devices? We use applications, whether it be games, or visit accessing the website through browser, or using email application to communicate, or you may be using a bank application for your transactions. So, these are the applications which help the user to access the remote servers and network applications. So, there are various applications like DNS, DHCP, which are the key applications which work behind the screen. What we use is most of the time the browsers, the FTP, the telnet, and the various applications that the vendors provide we use. But what happens behind is what we are going to learn and understand the basics of networking. So, the next layer we have below the application layer is the presentation layer, and let us look at the features offered by the presentation layer. The presentation layer provides different types of data representation. So, if you look at, if we are accessing a web page, and this web page provides some information. Let us suppose we go to a website right away. Let us go to www.zoomgroup.com, and what do we get from this web page? So, in this web page you can actually see some text, some information, and you can also see certain images. You can see some images, right, and then we have text. So, text and image are the various components that we have in this web page. So, these images and text are the different types of data, and we have to represent this in its original format, and this is possible by the presentation layer. So, if you look back into the presentation layer, it is representing the different data representation formats. So, the text has to be represented in the form of text, image has to be represented in the form of an image, voice have to be represented in the form of voice, and video in the form of video. So, this process requires the function called encoding and decoding. So, at the server computer or server device will encode the text in the text format, image in the image format, voice and video in this respective formats, and send the information to the destination, which is the user. On the destination device, the computer will decode and display the information in the web browser or the corresponding application. So, out of this, if you see, encoding and decoding are mandatory functions on the data, which must be performed for every data packet. But whereas the other functions like encryption and decryption, compression and decompression, these two functions are basically optional. They may be required or they may not be required for all the applications. But what do we mean by encryption and decryption? So if you want to see, the data should not be visible to others, whoever is capturing the data on the network. If you do not want the data to be visible to them, we have to encrypt the data. So when we encrypt the data is not in a readable format, and this data will be transmitted from the source to the destination. On the destination computer, the decryption function will happen and it will convert the unreadable format into the readable format. So the encryption and decryption are normally used for security purposes. Normally we encrypt these passwords when you are sending and receiving information. You want to log into your email, this password should not be visible. So we have to encrypt these passwords. So this presentation layer takes care of this functionality of encryption and decryption. The additional function it performs is compression and decompression. So if you see, there's a lot of data to be sent to the remote computer. The compression and decompression will help us to ensure that large amounts of data is compressed and sent in quick time. This was a function very widely used in the 80s and 90s because the bandwidth was very expensive. But today, with the globalization of internet and a lot of users accessing the internet, the cost of the bandwidth has come down drastically. So this feature of compression and decompression is not very common as it used to be. So from the application layer, we learned that we use these applications for interaction between the source and the destination, or between the PC and the server. Whereas the presentation layer, which works below the application layer, is responsible for data representation, be it text, image, voice or video. And this information which started from the application layer, which comes to the presentation layer, which goes down further to the session layer. So let's look at the next layer, which is the session layer. So session layer is the one which is providing the communication between the source and the destination. So what type of communication does it provide? Session establishment. When you want to send data, before you can actually send or receive data, between the source and the destination, there should be a session. Like for example, if you want to call and talk to somebody, you dial the number and the call gets connected. Only when the other person answers, the call is established between you and the other person. So similarly, between the two computers, if you have to send or receive data, the session layer is responsible to establish the connection. So once a connection is established between the source and the destination, then it has to maintain this connection as long as there is data transfer. And once the data transfer is complete from the source to the destination computer, the session layer will disconnect the session or close the connection or terminate the connection. This is as simple as our phone call. We dial the number and the call is established, and then you speak as long as you want to speak, and then once you finish talking to the person, you disconnect the call. So the call gets released. So session establishment, session maintenance and session termination. These are the key functions of the session layer. And to achieve these functions, we have these protocols which are RPC, remote procedure calls, which is available in every network operating system, whether it is Windows 7 or Windows 8 or Windows 10, Windows Server or other operating systems like Linux, Unix, various flavors of Unix and Linux, including the smartphone operating system like Android, Apple, BlackBerry, and all these also have these RPCs involved. Means it's part of the operating system, because to enable communication between the source and the destination, we need to create a session, and the session creation, session maintenance and session termination is performed by this RPC protocol. Apart from this, there are other examples of the session layer, that is SQL protocol, structured query language, and this is very widely used with the database applications like you have any database application, they use the SQL application. And in the Apple operating system, we have this protocol called ASP, Apple Talk Session Protocol. Its responsibility is a similar one which we discussed, creating a session between the client and the server and maintaining the session and then closing the session. These are the functions of the session layer. So, application, from application the request has come to presentation, and from presentation the request has come to session. So, the next layer, which is below the session layer, is called transport layer. And just before we go to the transport layer, the last function that this session layer performs is, during the establishment of the session, every session will be given a unique identity called session ID. So, the computer, whichever request it is making from the computer to the remote device, a session ID is maintained for every connection. A unique session ID is maintained for every connection it makes. And then the data goes from the session layer to the transport layer. So, let us look at what the transport layer has to do. So, this provides, the transport layer provides end-to-end control, meaning when you want to send or receive data, an end-to-end control is required, and that is taken care by the transport layer. And we can see here some of the functions that this transport layer is performing. Identification of service. So, transport layer should be able to identify which service is being used. Are we using the web service? Are we using the email service? Are we using the DNS service? Are we using the DHCP service? Like this, there are so many different services available. So, these services require to be identified by the transport layer, and this identification of service is done by using the port numbers. So, let us look at what are port numbers. So, port numbers define the services. So, the port numbers start from port number 1 and goes on up to 65,535 port numbers. These many port numbers exist, and these are categorized again into two types of port categories, that is open ports and reserved ports. Open ports are those which come under the range of port number 1 to 49,511, and then the reserved ports are coming from 49,512 up to 65,534. So, open ports are those reserved for applications, and it acts as destination port, whereas reserved ports are used by the source, and then it is called as source port. So, port numbers are very important and are used for every communication. Suppose you want to access a web page. So, the web page is requested from the local browser of the computer. Let us suppose in this example, let us say this is the PC and this is a server. So, for the time being we will consider that this is a server. So, if you have to access from the PC to the server, then we need to open the browser and access web server. This is a web server. So, from this PC, when we access the web server, the computer will use both source port number and the destination port number. So, the source port number can be any number, random number, and the destination port number will always be a reserved port number. For web services, the port number is 80. The web services, the port number is 80. Web services uses port number 80. So, this is reserved. Okay. So, we can also verify this communication happening from the source computer to the destination computer from our PC, where we can go to the command prompt of the computer and then running this command called netstat. By using this netstat command, it will display the various connections established from the local computer to the remote computer. So, you can see the various port numbers that are used and the various destination port numbers. You can see here HTTPS. So, HTTP and HTTPS are very commonly used port numbers. So, HTTP uses port number 80. Web requests are nothing but HTTP requests. So, let me show you. The HTTP protocol uses port number 80, and the HTTPS protocol is a secure protocol. It uses port number 443. So, this is the protocols HTTPS. So, HTTP is using port number 80, HTTPS uses port number 443, and these are coming under the reserved ports, and all reserved ports are used for the destination purpose. So, that is one of the functions of the transport layer. So, you can see the identification of service is based on port numbers, and then we have other functions like multiplexing and demultiplexing, which I will be discussing, and then we have segmentation, sequencing and reassembly, and then flow control and error correction. So, you can see that so many functions are performed at this transport layer, and that is one of the reasons why this is called as the heart of the OSI layer. So, let us look at what is happening at this multiplexing. So, when you open multiple applications like multiple browsers, browser along with FTP or Telnet, multiple application requests are coming and they are being multiplexed by the transport layer. The transport layer is responsible for multiplexing these functions, and when the request goes out of your computer and when the reply comes back, and when reply comes back, we will be using the function called demultiplexing. So, multiplexing is combining multiple streams of data into either TCP protocol or UDP protocol, and in the reverse process, when you receive data, the data comes as an input in the form of TCP or UDP, and then we have the demultiplexing, which will demultiplex and send the request to the corresponding applications. So, multiplexing and demultiplexing happens at the transport layer, and then we have, you can see the data flow from application to presentation, presentation to session, and then to transport. So, this transport layer is multiplexing these into either TCP or UDP stream, and when you receive data, they are combined into demultiplexed into TCP, UDP to different applications. So, multiplexing when you send data out, demultiplexing when you receive the data from the remote computer. So, we have the TCP and UDP applications, and they are all custom designed. I repeat, they are all custom designed. We do not have any role to play in terms of selecting the applications, whether it is TCP or UDP. It is the application developer which decides which protocol will be used or which transport protocol to be used. So, when you look at these functions or features of this protocol, TCP stands for Transmission Control Protocol, TCP. These applications which use TCP are connection oriented. There is a connection always between the source and the destination, and they are reliable because they send acknowledgements. So, when you send data, you get a confirmation that the data was delivered, and since we have to wait for the confirmation, the communication is slow, the data transfer is slow, and the protocol number reserved for the TCP applications is 6. And you can see here some of the examples of applications that use TCP. So, HTTP, FTP and SMTP. In short, when we access a web page through the browser, you may be using either HTTP protocol or HTTPS protocol. So, both of them use TCP application. FTP, SMTP is for email. So, all this uses the internal transport protocol called TCP. And when it comes to the UDP protocol, it stands for User Datagram Protocol, and it is connectionless. Connectionless in the sense there is no communication between the source and the destination. Means like the case of the TCP, there is no established connection. So, whenever you use the UDP applications, the data is sent and there is no confirmation, there is no acknowledgement for the data sent by the UDP application, and hence it is considered as unreliable because we do not have confirmation. And the reason why this application data is sent faster is because we do not have any waiting time. We do not have to wait for the acknowledgement. So, the communication in the UDP applications is much faster compared to the TCP applications. Then we have the protocol number for UDP reserved as number 17. So, we have a little while ago discussed about the port numbers. So, port numbers are allocated by the transport layer, whereas protocol numbers are allocated by the network layer. The examples of applications that use the UDP protocol for transport are DNS, Domain Naming System, and DHCP, Dynamic Host Configuration Protocol, and then we have TFTP. Apart from this, there are other applications like, for example, video conferencing, voice over IP. All the real time applications also depend upon this UDP protocol for data transmission. So, you can see the various functions performed by the transport layer. So, before we move to the network layer, let us quickly look at the functions that are performed by the transport layer. So, this layer will add additional data to the header, like for example, the source and destination port numbers are added, and the type of protocol, whether it is TCP or UDP protocol, are added, and the sequence number are also added to the additional information as an additional information. So, when the data arrives from the application layer to presentation layer to session layer, and session layer to transport layer is adding these additional information to the received data. And this process of adding this additional information is called as encapsulation. Encapsulation is the process of adding additional information to the received data. And then we have the next layer, which is the network layer. So, network layer provides end-to-end data delivery. Remember, the transport layer was only defining how the data should be sent, whether through TCP or through UDP, but network layer is one which is responsible for the data delivery. So, the data delivery on the network layer is possible through two different protocols called routed protocols, which are actually called the data carriers, and then routing protocols. These routing protocols are the ones which show the path for the packet to reach the destination. And you can see the various routed protocols here: IP, AppleTalk. But among all these protocols, IP is the only protocol that is in use today. All other protocols have been outdated. They are no longer used. And under the routing protocols, we have various dynamic routing protocols called EIGRP, OSPF, RIP and BGP. So, these are the various dynamic routing protocols which help the users to communicate with the corresponding destinations. So, we can look at as an example that when we access internet, how does our computer know where this yahoo.com is, or where the zoomgroup.com is, or where cisco.com is? We do not know where that server exists. but we are able to communicate. How is it possible for your computer and to know where the destination is? The physical server, the yahoo.com or zoomgroup.com or google.com servers, they are available on internet, but where in internet? Whether it is in India or is it outside India? Where is the server hosted? We do not know, but we are capable of reaching that web page because of the help of this routing protocols, and that is a function of the network layer. So network layer has two kinds of protocols. They are routed protocols, and these routed protocols help to carry the data from source to destination, and the routing protocols help to show the path how to reach the destination. And the examples of network layer are hardware devices called routers. So let's have a look at how the routers will look like. So this layer controls the data communication from one network to another network, or it facilitates the communication from one network to another network. And this OSI layer network model, OSI model network layer adds the source IP, who is sending the data, and destination IP, to whom this data is being sent. And the example of the device that works at the network layer is the router. And this is the picture of the router. You can see here, these are the different categories of routers. You can see these are all Cisco routers, 3 different products available for small, medium and large organizations. And this router is also called as a layer 3 device. So this device is facilitating the communication from one network to another network. And we can see we have a small router at home. We have a router at home which is connecting from the ISP to our home, and from our smartphones and tabs and computers we are connected to this router. We call that as a Wi-Fi router. It is also a router, a layer 3 device, which is allowing us to communicate from our local network to the remote network. And then we have the next layer, which is data link layer. This is also called layer 2, and it provides error control and synchronization of the data. This is the function of the data link layer. So it provides source MAC address, means which device is sending the data, that device's MAC address, also called layer 2 address, and the destination MAC address. So for any network communication, we require 2 unique addresses called source IP address and source MAC address of one device, and to which device you want to communicate, that is destination IP address and destination MAC address. So IP address and MAC address both are necessary for data communication in the network. So without any one of these, data communication is not possible. And IP addresses are taken care by the network layer, and the MAC addresses are taken care by the data link layer. The other function of the data link layer is also for a reliable transmission of data, and that is possible with a protocol called CRC, which stands for cyclic redundancy check. The CRC protocol is responsible for ensuring that the data is reliably sent. If there is a packet damaged on the transit because of collisions or broadcast, and this packet will be removed, will not be delivered to the destination. And then the output of this layer, we call it as frame. Frame is called as a protocol data unit, and the example of this layer is called as switch. So switches that we use in our network, let us see this picture. So this is a picture of a switch, and it is called as layer 2 device. So we have seen a router which allows communication from the local network to the remote network, and this is the picture of a switch which allows the communication between the devices within our own local area network. So we have discussed about the various networking devices which were important for network communication, and the last layer of the OSI model we have is the physical layer. In the physical layer, it is only responsible for transmission of data, physical transmission or maybe wireless transmission. So we have 3 different types of physical interfaces on the devices, on the PCs, computers, servers, printers, etc. We have copper wire connectivity, in the form of UTP cable or STP cable or fiber optic cable and also wireless. These are the three different physical media that is available for connecting the various network devices in the network. And the output of this layer is called as bits. The output of this layer is called as bits. And the example of the hardware devices that are used in this model are called as hubs and repeaters, and we can actually see an example of a hub. You can see there are 4 ports available here, 4 different computers can be connected to this hub. But hub is not an intelligent device and widely not used by organizations because it broadcasts every communication. You send data from computer A to computer B, but this device will forward this message to all other devices connected to that particular hub. Whereas switch is an intelligent device and it will send data only to the designated computer. So, it is intelligent. So, with this we complete all the 7 layers of the OSI model, and we have seen the functions of each of these layers. As a network engineer, as a systems engineer, what is important for us is the physical layer, the data link layer and the network layer. These layers are related with network communication. And now we have the conclusion of the OSI model. We can see here on the screen the PDU, protocol data unit. So, every layer sends some information out to the next layer, and that output is mentioned as protocol data unit. So, if you see, the application layer output is data, and this data goes as input to the next layer, and when you send the data out from presentation layer, the output is data, means we are not adding new information to it, and that the data is sent to the session layer and the output is again the data. So, the data that comes out of the session layer is going to the transport layer, and at the transport layer, remember, we are adding additional information like source port number, destination port number, etc., and we call the output as segment. So, encapsulation takes place at the transport layer, and this segment, when sent as input to the network layer, the network layer will add source IP address and destination IP address, and we call that as packet. So, the output of the network layer is packet, which goes as input to the data link layer, and in the data link layer it will add the source MAC address, the destination MAC address, the CRC values, and this output of the data link layer is called as frame. These components are very important. You must know all these protocol data units. And in the physical layer, there is no new header being added. It directly converts the frames into the bits depending upon the physical connectivity we have, either in the form of copper or fiber or in the form of wireless communication. So, this is the conclusion of the OSI model, and now we are going to look at the next model, which is the TCP/IP model. But remember, OSI model is just a reference model. It is not used in any of the operating systems for data communication, but it is used as a reference. So, when we discuss about the TCP/IP model now, and we will compare how the TCP/IP and OSI layer can be mapped. So, we have the TCP/IP model, which is the most widely used data communication model across the world. Every operating system supports TCP/IP model. The current version of the TCP/IP is IP version 4 or TCP/IP version 4. This was first developed and tested in the year 1975 and became operational in 1981. So, it consists of 4 independent layers, unlike the OSI model, which consists of 7 independent layers. And without this TCP/IP protocol, we would not be able to access internet, we would not be able to have any type of data communication. So, this is the most important type of protocol. In this, we have 4 independent layers called application. You can see the name is common from the OSI model. We have the same name, application layer, and the transport layer, then we have internet layer, and then the link layer. So, these are the 4 layers, and the functionality is similar. Application layer provides process to process data exchange for applications. Like when you open a web page, the web page is using this application layer and providing the communication. Transport layer is providing host to host communication using either TCP or UDP protocol. Internet layer is providing the identification, that is IP addressing and routing. Routed protocols and routing protocols work in this internet layer. And finally, the link layer provides physical connectivity and the communication methods. So we can say that OSI can be compared with TCP/IP, and the one which we use for our day-to-day data communication is the TCP/IP model. So you can see here the first three layers of the OSI model are being mapped with one layer in the TCP/IP model. So the individual functions that we discussed in all these three layers is mapped with one single layer of the TCP/IP model. And the transport layer function which we have discussed, we also said that it is performing so many different tasks like identification of service, multiplexing and demultiplexing, segmentation, sequencing and reassembly, and the flow control, error correction. All these functions are performed by the transport layer. So the same functions are performed in the TCP/IP model also. So the network layer is the one which is intelligently sending the data from source to destination, and it does the same function here also. The network layer is called as internet layer. The name got changed here in the TCP/IP model. The network layer of OSI is called as internet layer. And the functions that are performed by two layers, that is data link and physical put together, is called as one single layer in the TCP/IP model called link layer, which provides data communication as well as physical connectivity. So we can map the 7 independent layers of the OSI model have been mapped with 4 layers of the TCP/IP model, and it is the TCP/IP model that we use today for our data communication. So in short, without TCP/IP model, we will not be able to send or receive data. So this is the most important protocol or the suite of protocol which establishes data communication between the source and the destination. So in this session today, we have discussed in detail about both the OSI model and the TCP/IP model, but actually the OSI model is called as a reference model because we can look at the functions that are performed in each layer and then map them to the corresponding TCP/IP model. So without TCP/IP, there is no way we can communicate. So the TCP/IP protocol became operational in the late 70s and the early 80s, and this identification of the each device in the network in the TCP/IP model is based on IP address. IP stands for Internet Protocol. So in the next session, we will be discussing more in detail about this IP addressing and actual data communication, the various devices that we have discussed, that is router, switch, and how they connect, how they communicate, how to configure these devices, and in detail we will understand the end-to-end communication of networking. So let us quickly look at this picture here. So we want to establish data communication from this PC as a source to this PC as a destination. So this is the source and this is the destination. To establish communication, we need applications which we have discussed both in the TCP/IP model as well as on the OSI model. So an application has to be used, maybe web browser or FTP or telnet, but in that application we have to give the information about the destination to whom we want to request information. So the source and destination are required. So we have source IP, destination IP. We have source port number, we have destination port number. We have source MAC address, we have destination MAC address. And then we need the media for communication. Without media, you will not be able to send or receive data. And the switch as a layer 2 device or a data link layer device will forward the data from source to destination. So we have discussed about the actual data communication with reference to the TCP/IP model. So we will conclude this session today, and then we will go and discuss about this functionality in the next session. So thank you for watching this video. We have discussed about the networking basics and networking advanced. In the next session, we will learn more in detail about these networking devices. Thank you.